For number 17, we're finding the area of the sector. So that would be the shaded region. So we would have the area equals the angle, which is 60, divided by 360, times pi r squared. And r squared this time is 8 squared. And so what I would do is I would do 60 times 64, and that would give me 1,000. Let's check. 60 times 64. So that would be 3,000. $840 divided by 360 times pi. So again, I did 60 times 64, got 3,840 divided by 360, and then my pi value is 3.14. So I would divide these first, and then multiply that by 3.14, and my area is 33.49, round to the nearest hundredth. So 3 makes the 9 stay the same. So that would be inches squared. Okay, so for number 18, if I want to find the area of this sector, I would do 23 divided by 360 times pi. R is 5 feet, so 5 squared. So we know 5 squared is 25, so I would do 25 times 23. So 575 divided by 360, and then I multiply that by 3.14, so it tells me to right here in the directions. So this is 5.015. The 5 makes the 1 go to a 2. So 5.02 feet squared would be the area of just that little sector, that section. Okay, number 19 says find the scale factor, perimeter ratio, and area ratio of the smallest to biggest shapes. Okay, so I go small to big, so that'd be 5 to 10. That reduces to 1/2. The scale factor is 1/2 then. Your perimeter ratio is the same as your scale factor, and your area ratio is just 1 squared, 2 squared, and you just rewrite the ratio 1/4. Okay, so in number 20 we have 3 to 8. Okay, that can't reduce. So again, it's the same. And then 3 squared, and then 8 squared, 64. So 964. For 21, we find the ratio, scale factor. So I did small to big, and I have 8 over 24 is 1/3. If I have to find the area of the other figure to the nearest whole number, so the larger pentagon is 135 centimeters squared. I'm finding the smaller area. So I know that I have 1/3, but this is the scale factor. I need to find the area ratio. So I square each of those. And then I don't know the small area, but the big area is 135. So 1 squared and 3 squared, 1/9, x over 135. So 9x equals 135. Okay, so if I divide those, we get 15 centimeters squared. And then in the last one for this page, number 22, the parallelograms are similar. Find the scale factor, perimeter ratio, and area ratio from small to large parallelogram. So first, I set them up as a fraction, 20 over 245. And because these are areas, and I need to get to scale factor, I need to reduce these because I can't take the square root of 20 and 245. So I divide those by 5. And that gives me 4/49. Now, that is the area ratio. But to get the scale factor in the perimeter, I just square root 4 and 49. So the square root of 4 is 2, and the square root of 49 is 7. And then we know that the perimeter ratio is the same thing as the scale factor. So it would be 2/7. For the last two, we're just going to graph those. So we've got 7, 9. It does say we should label, well, it doesn't actually say to label, but you should always label. Okay, so now we know that that's a kite. The area formula for a kite is 1/2 diagonal 1 times diagonal 2. So if I count my diagonals, okay, this diagonal here, let's count that. I got 16, so diagonal 1, 16, and then diagonal 2 would go from B to D, okay, and that would be That would be 18. And then what I would do is I would just take those two diagonals and I would plug them into the formula. And 16 times 18 is 288. But according to the formula, I have to cut that in half. And so my final area would be 144 units squared. So for the last problem, I would go ahead and graph my points. Okay, so we can see that we have a trapezoid. The formula is 1/2 times the height times the sum of the bases. And so I need base 1, base 2, and the height. Alright, so bases. Top base, that's 6. Bottom base, 12. And the height, let's count that. So from the top base to the bottom base, so 1, 2, 3, 13. Now I just need to plug all of those numbers into the area formula. So the height was 13, and the bases are 6 and 12. So if I add the bases, I get 18. 18 times 13 is 234. And then I just take half of that, which is 117. And again, that's units squared.